Yo, just back on discrete math and its applications. I'm on 1.4. This next chapter starts in like other 40 pages, so there's still quite a bit to go. Man, is it? No, it's like, yeah, another, 70 pages. So it doesn't really matter. Not the point. So far, just learning about logic, like the symbols and stuff that are used, what they mean. So, negation, implication, stuff like that. What is the other one? The double-sided arrow. Quantifications. Yeah, what is the double-sided arrow? I can't remember. It's just like equivalence? Is it? I feel like it's not the correct way. I feel like it's not the correct one. It's like equivalence. Oh, it is. I think so. Equivalence. Alright, anyway. So I'm going to start with 1.4 sets. Which goes into set operations. Okay. I've already read a bit of sets actually, so. Oh yeah, just relaxing with the music, having a good night. What is this? It's talking about, well, not LibreOffice, so. Oh yeah, I downloaded LibreOffice today. I think that what I was using was OpenOffice, so that might be what it's called. But they're talking about George. I want to show George Cantor set theory paradoxes. What are they? Cantor's paradox? Okay, Cantor's paradox states that there is no set of all cardinalities. Oh, I don't know what that is, cardinality. In mathematics, cardinality is an inherent property of sets, roughly meaning the number of individual objects they contain. What? One correspondence between a set map and a submargin should they have the same cardinality. Okay, so the amount. Here's another example of, I mean, not just mathematics, but just like higher education in general. Just a lot of the battle is understanding what seemingly obscure terms mean. And I come back to this a lot, but like, here's a perfect example of cardinality. roughly meaning the number of individual objects they contain in a set. Not very hard to understand, right? So, if you ever find yourself in a situation where a quote-unquote learned person or an educated person is talking at you in terms that you don't understand, don't immediately just assume that this means they're so smart and all this and all that. Honestly, a lot of the time people hide behind terms. And I'm not saying this is even an example of that, but just generally speaking, I've encountered that in my life more than once. And then I went and learned what the terms meant and what they were talking about, and it was fairly simple. Anyway, so yeah, cardinality. So what is this Cantor's paradox? It states that there is no set of all cardinalities. Okay. No greatness cardinal number. Okay. That's interesting. So anyway, that's something briefly discussed here. Wait a minute. Here's a very interesting thing. We're going to test this right now in Python. Maybe. Oh, here it is. So this book is saying that a set to be equal with another set must just contain the same elements, meaning it was saying like the set, 1, 2, 3 is equal to, 3, 2, 1, which isn't very hard to grasp, but it was also saying this would be equal to, it was saying the frequency doesn't matter, so 1, 1, 2, 3 is equal to these. Right, so let's see what Python has to say about this. So set 1 will be 1, 2, 3, and then set 2 will be 1, 1, 2, 3. Okay, and then we'll just simply say set 1 equal to set 2. True. That's interesting. Who knew that? Did you guys know that? I didn't know that. That is interesting. In fact, I want to send this to my friend. Send this. Yeah, that's cool, guys. So, Python agrees. Okay. Another way to describe a set is just set builder notation. Set builder notation seems so mathy. I mean, like, who... Raise your hand if you've used set builder notation. I mean, hats off to you. Never met a guy in my life who used set builder notation. What is this playing? It's not bad, but it was not what I was expecting. Kind of wanted some lo-fi core. So we're going to do that instead. Interesting. Another interesting thing. Oh wow, look at me. I put that right in front of the thing. Another interesting thing. The null set is a subset of every set. That's very interesting. I mean, it seems to be kind of like a gotcha. Because, like, yeah, it's null. Therefore, it can just be a part of anything. That's interesting. To establish that the null set is a subset of S, we must show that every element of the null set is also an S. You see what I'm saying? That's really funny. Because there's nothing in the null set. In other words, we must show that the implication if X belongs to null, then X belongs to S is always true. We need only to note that the hypothesis of implication is always false. Okay. I'm gonna have to go to bat on this one. Let's see what this has to say. I mean, yeah, that's obvious, but this book brings up some sort of logical argument to prove it. Jeez, guys, you want to zoom in a little bit? There you go. That's actually good. Thank you, this guy from 2013. Who's this guy? R. Schweeb. Last seen this week. Okay. Appreciate. Let's shot this guy real quick. Who is this guy? I don't know. Ah, blah blah blah. Anyway, I like this one better. Can you come up with a set A such that there exists X belonging to the null set, but X not belonging to A? That's what's necessary to show that null set is not a subset of A. Put in those terms, it's better. I agree with you, R. Schweeb. Or whatever your name is. I think it's R. Schweeb or something. Wait, yeah. That's pretty much saying if A is a subset, oops. If A is a subset of B and B is a subset of A, then A equals B. That's interesting. Cardinality. There you go. Here's another one. The one in algebra is absolute value bars, and discrete math is like denoting the cardinality or the size of the set. So I was seeing this in my algorithms course. It was like absolute value. It's not absolute value. It's size. Discrete math, different math. I did catch on eventually that it meant size, but I was just like a bit confused the entire time all the way through. Jeez, cheers, guy. Sinking down. We will also be interested in sets that are not finite. Oh, Lord, have mercy on me now. Set is said to be infinite if it is not finite. The set of positive integers is infinite. Okay. The power set What? The power, given a set S, the power set of S is the set of all subsets of the set S. That is funny sounding. So like permutations, right? Or maybe not permutations, because the order doesn't matter, actually. Oh, anyway. What is the power set of the set 0, 1, 2? Lord, I think there's quite a few. Yeah, I would think. What's that, huh? That's interesting. And maybe quick. Alright, here we go. Man, I need to shave my face. I'll do it tomorrow morning. Cartesian product. Rene Descartes. What a freaking beast. You learn about Rene Descartes everywhere. You learn about it in philosophy. You learn about him in philosophy. You learn about him in like neuroscience. You learn about him in like psychology. You learn about him in mathematics. You learn about this guy everywhere. So you might as well learn about him in this street real quick. I'm gonna just show you a little picture of Rene Descartes just in case you've never seen it before. Maybe you have. I don't know. Maybe you've never seen him. Rene Descartes. This guy right here. This guy is he's omnipresent, whatever you want to say. Oh gosh. fella right here, Rene Descartes. I think he's French. Was he a French guy? Yeah, French guy. One of my favorite French guys right here, Rene Descartes. He really thought about stuff. He really did. Died at 53, it's sad. Where's this place in France? Is that Descartes? Oh. Oh, they freaking named it after him? Hmm. They gotta, yeah, that's beast mode. Texas. Oh, it's fantasy baseball. Alright, I think that's gonna be enough. Just some short reading. Got through 1.4. Oh, I'm getting tired. I gotta wake up early, so. Nice to finish the day off with some stuff like this. Alright, see you later.